So, hello everyone again, this is lecture 4 part 2 of ray optics and optical instruments. Today we will start with the refraction through a prism concept. In the previous lecture we completed the complete discussion on power of a lens and combination of thin lenses in contact. Today we will start with a new discussion. So, I am Sameer Lavankar, let us begin our discussion. Okay, so right now we are on the sixth part, that is refraction through a prism. So, let us move on with this discussion only today, let us not waste any time. Okay, so refraction through a prism. So, figure shows the passage of light through a triangular prism ABC. So, first of all let us look over to this prism. Let me just explain everything what is happening here, so that we can understand much more clearly what is complete refraction through a prism. So, first of all this is a 2D figure of a prism. As you can see, this is the triangle ABC being formed here. Okay. This is the incident light. So, incident, let me just keep on writing everything. So, incident light, that is PQ, fine. Next is the emergent light, or first of all let me write the inside light or refracted light here. So, let me write it as refracted light or inside light. So, this is just my denotation only, there is no need to remember it as inside light. So, this is nothing but your QR, and then there is emergent light. So, emergent light is nothing but RS, fine. So, you know this what is happening. So, after first refraction and this is after second refraction, fine. So, this thing is also been explained. Then quite evident there will be a normal being drawn here. So, this is the normal, again this is again normal. So, these are two normals basically, just let me write here. So, NQ, or let me write like this. So, normal lines are NQ, and next is your NR, NQ and NR. So, these are two normal lines here. Then next is so angle of incidence has been found, quite evident. So, this will be the angle of incidence. Similarly, with the angle here normal NR and the emergent right E, angle E is formed, that is angle E is nothing but angle of emergence. Then there is something called as angle of deviation. This angle of deviation will be explained to you when I will try to go here directly. So, just wait for some time. Then angle R1 and angle R2. What is the angle R1 angle R2? So, this is for the first refraction, this is for the second refraction. Okay. So, this is the complete explanation. So, just this is nothing but the angle of deviation basically. Okay. Let us move on now. So, figure shows the passage of light through a triangular prism ABC. The angles of incidence and refraction at the first phase AB are I and R1, quite evident. This is I, this is R1, while the angles of incidence from glass to air at the second phase AC is R2, and the angle of refraction or emergence is E. Quite evident, this R2 becomes the new angle of incidence now. So, this is the angle of incidence and this is the angle of refraction. If let us suppose the direction of propagation would have been in opposite direction, then this would have become angle I or angle of incidence, and this would have become the angle of refraction only, fine. Okay. So, this thing is also been explained. Let us move on. The angle between the emergent ray RS, the angle between the emergent ray. So, this is the emergent ray basically, and the direction of the incident ray PQ, and direction of incident ray PQ is basically this angle, which is called as angle of deviation. Okay, what is the actual formulation? We will try to understand in the subsequent points. Let us move on for now. In the quadrilateral AQNR, so let us move on. So, what is AQNR? So, AQNR is basically this. So, this is your AQNR, two of the angles, that is at the vertices Q and R, are right angles. Quite evident, as you can see, this is nothing but the normals being drawn, hence this will be equal to 90 degrees, and similarly this will be equal to 90 degrees. Now from the basic mathematics geometry concept, we know that the summation of all the angles, interior angles of a quadrilateral, is equal to 360 degrees. Therefore, as both angles are 90 only, therefore angle QAR and angle QNR, the summation of both of them will be equal to 180 degrees. Therefore, the sum of other angles of the quadrilateral is 180 degrees as written here. Hence, angle A, so this is the basically the angle A, and angle QNR is equal to 180 degrees. Now, from the triangle QNR, so QNR is this triangle, just let me denote it by some other color. So, this is your angle QNR. Angle R1 plus angle R2 plus angle QNR is equal to 180 degrees, quite evident. So, basically now we have two equations, and comparing these two equations, what we can get, that R1 plus R2 is equal to angle A. So, this is the first formulation what we got from this, that is summation of R1 and R2 is equal to angle A. That is, what is angle A? Angle A is the angle of the prism. Okay. Next thing is total deviation angle delta is the sum of the deviations at the two faces. So, what is the deviation at two faces? From where does the name angle of deviation is derived? So, angle of deviation, as in the amount of difference in the angles at the two locations. First is the angle I minus R1 and second is angle E minus R2. So, just writing it here. So, therefore, we will get delta is equal to nothing but I minus R1 plus E minus R2. So, it is nothing but I plus E minus R1 plus R2. Hence, it is equal to I plus E. From this equation, we can get minus A. Therefore, if you know the value of angle of incidence, if you know the value of angle of emergence, if you know the angle of prism, then you can find out the value of angle of deviation. So, therefore, the total angle deviation is nothing but equal to I plus E minus A. Let us move on. Thus, the angle of deviation depends on the angle of incidence, quite evident. So, as the angle of incidence keeps on changing, you can find out the different angles of deviation. Okay. Now, plot has been created here, as you can see a plot has been created here, which is between the angle of deviation, that is delta, and also the angle of incidence is shown in the figure. So, as you can see, for just leave this portion, apart from this portion, for any angle of incidence, for any angle of deviation, you can find out two different values of angle of incidence. So, basically even at this angle and this angle, the angle of deviation is same. Okay. So, a plot between the angle of deviation and the angle of incidence is shown in the figure. As you can see in general, that any given value of delta except for I equal to E corresponds to two values of I and hence of E, quite evident. So, basically either direction of propagation can be in this direction or the direction of propagation can be in opposite direction. Therefore, the value of angle of I can be twice, and similarly E and I can interchange. So, this is the explanation being explained here. So, you can see that in general any given value of delta except for I is equal to E corresponds to two values I and hence of E. This in fact is expected from the symmetry of I and E in the above equation, and that is delta remains the same if I and E are interchanged, quite evident, because we know that delta is equal to I plus E minus A, which is also equal to E plus I minus A. So, even if both of them gets interchanged, there is no change in the angle of deviation. Okay, fine. Next thing is physically this is related to the fact that the path of ray in below figure can be traced back, resulting in the same angle of deviation, quite evident. Simple mathematics is being explained, that it is related to the fact that path of ray in the below figure can be traced back, resulting in the same direction of deviation. That is, if we just change the direction of propagation, we can find out it can be traced back. So, we can just directly go to that laser of the source of the light. Fine. At the minimum deviation dm, the refracted ray inside the prism becomes parallel to its base. So, what is happening here is that the at the minimum deviation dm so what will happen in dm at dm I is equal to E will happen. So, at the minimum deviation dm, the refracted ray inside the prism becomes parallel to its base. That means, this line and this line are parallel, nothing else, this has only been explained here. We have d is equal to dm, that is I is equal to E, which implies R1 is equal to R2. So, at the only condition when the minimum deviation is happening, at that location, first of all I is equal to E and second is R1 is equal to R2. Therefore, just using the formulation for from previous equation. So, we have R1 plus R2 is equal to A. Therefore, what we will get? We will get that R2R. So, basically R1 plus R2 is equal to A. Therefore, 2R1, or we can just write it as R is equal to A. Therefore, we will get R is equal to A by 2. So, basically the angle of refraction would be nothing but the half of the angle of prism. Moving on, so in the same way delta, that is what is dm here? Dm nothing but the angle of deviation. So, angle of deviation delta is nothing but equal to I plus E minus your R1 plus R2, right. Therefore, in the place of I and E you can just write I is equal to E, therefore, you can write 2I, and similarly in the place of R1 plus R2 you can just write A only directly. Therefore, what you got is I is equal to nothing but delta plus A by 2, or just writing it as dm here. So, therefore, it will be dm plus A by 2. So, now just what you need to remember for this complete refraction through a prism is what is the refractive index of the prism. So, to find out a refractive index of the prism, the refractive index of the prism is nothing but sin I by sin r. Therefore, we will get sin of I by sin of r. Therefore, sin of I, we just derived it, that is equal to A plus dm by 2 upon, in the previous equation we derived for r is nothing but A by 2. Therefore, this will be equal to sin of A by 2, and hence this is the equation being written here. That is refractive index of the prism is n21, which is equal to n2 by n1, which is equal to sin of A plus dm by 2 upon sin of A by 2. Hence, this is the complete formulation for refractive index. Okay, let us move on. So, the angles A and dm can be measured experimentally. Equation thus provides a method of determining refractive index of the material of the prism. Now, for a small prism, so these were just the formulations. So, angle A and dm can be measured experimentally, quite evident, you can measure this. Equation thus provide a method of determining refractive index of the material of the prism. So, basically you know this, and you know this, hence you can find out the value of refractive index of the prism. For a small angle prism, that is a thin prism dm is also very small, and we get so basically we can use sin theta is approximately equal to theta. Therefore, you just delete sin from both of this, and hence dividing it by 2 gets cancelled, and hence you can get this, that just let me write it here. Therefore, you will get n21 is equal to A plus dm upon A, which is equal to 1 plus dm upon A. Therefore, n21 minus 1 is equal to dm upon A. Hence, we will get dm is equal to A into n21 minus 1. So, basically you can find the angle of deviation, which is equal to A into n21 minus 1, or refractive index n21 is equal to nothing but 1 plus dm by A. Okay. It implies that thin prisms do not deviate light much. Fine. So, very little deviation happens for thin prisms. So, that is the end of your refraction through a prism also. So, that is the end of your refraction through a prism. Let us start with the final concept of this chapter, that is ray optics and optical instruments, that is optical instruments. So, let us look over to all the different types of optical instruments: magnification, magnifier, telescope, etc., microscope, telescope, etc. Okay. So, optical instruments. So, a number of optical devices and instruments have been designed utilizing reflecting and refracting properties of mirrors, lenses and prisms, quite evident. So, this is nothing the theoretical introduction part. Periscopes, kaleidoscope, binoculars, telescopes, microscopes are some examples of optical devices and instruments that are in common use. Okay. Our eye is of course one of the most important optical device that the nature has endowed us with. We can now go on to describe the principles of working of the microscope and the telescope. So, basically we just need for the complete 12th class syllabus, you should know the principles of working of microscope and telescope. Okay. So, let us move on. So, the microscope. Okay, let us start with the concepts of microscopes now. So, what is happening, as you know what is microscope? Microscope is being used to find out or to magnify very small minute details. What is the principle, what is the use of a telescope? Telescope is used basically to find out magnified image of the objects which are very distant apart from each other, such as moon, stars, etc. Okay. So, let us start first of all with our microscope only. So, a simple magnifier or microscope is a converging lens of small focal length. So, basically what is happening, first of all it is a converging lens. What does it mean, a converging lens? Basically it is a convex lens. So, it is a convex lens, and next thing is that the focal length is very small, first thing. Next thing is in order to use such a lens as a microscope, the lens is held near to the object. So, basically what we try to do is we held, as you can see, even if you may have used microscope also. So, whenever you try to view any very small thing, you just put it on the sample, you put glycerin on it, you put the small box, and then you keep the image, you keep the microscope very near to it, and then you try to view it through the lens. Okay. So, in order to use such a lens as a microscope, the lens is held near the object, one focal length away or less, and the eye is positioned close to the lens on the other side. Fine. The idea is to get an erect, magnified and virtual image of the object at a distance, so that it can be viewed comfortably, that is at 25 centimeters or more. So, what is the basic agenda? What we need? Well, we need an erect image, it should not be inverted, it should be magnified, of course, it should be magnified because we are trying to see very small particles. And the third thing is that we should find out that it has to be it has to be viewed at a location such that it is viewed comfortably. When can we view it comfortably? So, an object, general eye can view it very clearly if it is at a distance of 25 centimeters from you or more. So, more is always valid. Okay. So, the idea is to get an erect, magnified and virtual image of the object at a distance, so that it can be viewed comfortably, that is at 25 centimeters or more. If the object is at distance f, the image will be at infinity. So, that will not happen. So, we cannot use it. So, because if the image is at infinity, we will not be able to view it. So, basically it is designed, it is being explained, or it is being utilized in such a way that the object is less than focal length. Okay. So, if the object is at a distance small f, the image is at infinity. However, if the object is at a distance slightly less than the focal length of the lens, the image is virtual and closer than infinity. Okay, fine. Although the closest comfortable distance of viewing the image is when it is at the near point, that is d is equal to 25 centimeters, it causes some strain on the eye. Everything which I already explained to you. So, there is nothing new here. Therefore, the image formed at infinity is often considered most suitable for viewing by the relaxed eye. So, therefore, when the image is formed at infinity, it is often considered most suitable for viewing. So, now we show here both cases. The first is figure A, that is eye focus on near point, and second is in the figure B, that is eye focus on infinity. So, whatever happens, if it is focus very near point, basically it will not be very easy to view for a larger duration of time, it will put strain in your eyes. But if you will view it as an object which is image which is formed at infinity, then it is much more easier or much more suitable to view it. Okay. So, I will try to explain it much more clearly in the next class. Let me stop it here for now. That will be the part in which we are going with the optical instruments completely. So, let me stop it here. So, basically the microscope will happen with magnification parts and so on. We will try to find out the actual formula, mathematical formula for magnification for microscope and telescopes differently. Okay. So, let me stop it here. Thank you so much.